Hey everybody, hopefully you're all having an awesome day today. Welcome back to my channel. I'm WireDogSec and I have another video for you guys. Today's video, we're going to be continuing on with the pre-security learning path to try hack me. And we are in the network fundamental section, and this room is the OSI model. Learn about the fundamental networking framework that determines the various stages in which data is handled across the network. Without further ado, let's go ahead and jump into it. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. Task 1. What is the OSI model? Scroll down a little bit. It says the OSI model, or Open Systems Interconnection Model, is an absolute fundamental model used in networking. This critical model provides a framework dictating how all network devices will send, receive, and interpret data. One of the main benefits of the OSI model is that the devices can have different functions and designs on a network while communicating with other devices. Data sent across a network that follows the uniformity of the OSI model can be understood by other devices. The OSI model consists of 7 layers, which are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer, the data travels through. Specific processes take place and pieces of information are added to this data, which is what we'll come to discuss in the upcoming tasks within this room. However, for now, we only need to understand that the process is called encapsulation and what the OSI model looks like in the diagram below. Now, to easily remember this, you can say something like, all people seem to need data processing, or please do not throw sausage pizza away. All right, just a little ditty there that can help you remember this. All right, so let's see here. What does OSI model stand for? All right, we already know that. Open Systems Interconnection Model. Go ahead. How many layers does it have? Well, we saw up above in diagram, there are 7 layers. There we go. And oops, let me fix that here. There we go. All right. Now, should be 7. What is the key term for when pieces of information get added to data? Remember, that's encapsulation. There we go. And let's go ahead to task number 2 here. We're going to talk about the application layer. All right, let's get into it. The application layer of the OSI model is the layer that you will be most familiar with. This familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with the data sent or received. Everyday applications such as email clients, browsers, or file servers, browsing software such as FileZilla provide a friendly graphical user interface, also known as a GUI, for users to interact with data sent or received. Other protocols include DNS, domain name system, which is how website addresses are translated into IP addresses. And it has a little example here of what they're describing here for the application layer. What is the name of this layer? Remember, it's application, so let's go ahead and type that in here. Application, all right. What is the technical term that is given to the name of the software that users interact with? And what did they call that up here? The graphical user interface, right? There we go. Right there. Also known as the GUI. All right, layer 6 for task number 3 here, and this is the presentation layer. Layer 6 of the OSI model is the layer in which standardization starts to take place. Because software developers can develop any software, such as email client, differently, the data still needs to be handled in the same way, no matter how the software works. This layer acts as a translator for data and from the application layer. Layer 7 The receiving computer will also understand data sent to a computer in one format destined for in another format. For example, when you send an email, the other user may have another email client to you, but the contents of the email will still need to display the same. Security features such as data encryption, like HTTPS, when visiting a secure site, occur at this layer. All right, what is the name of this layer? That's the presentation layer, as we see up above. There we go. And what is the main purpose that this layer acts as? And should be the translator for this one. And there we go. Layer number 5, we're going to talk about the session layer. Once data has been correctly translated or formatted from the presentation layer, layer 6, the session layer, layer 5, will begin to create a connection to the other computer that the data is destined for. When a connection is established, a session is created. Whilst this connection is active, so is the session. The session layer, layer 5, synchronizes the two computers to ensure that they are on the same page before data is sent and received. Once these checks are in place, the session layer will begin to divide up the data sent into smaller chunks of data and begin to send these chunks, also known as packets, one at a time. This dividing up is beneficial because if the connection is lost, only the chunks that weren't sent yet sent uh, will be sent again, not the entire piece of the data. Think of it as loading a save file in a video game. What is worthy of noting is that sessions are unique, meaning that data cannot travel over different sessions, but in fact only across each section instead. What's the name of this one? Remember, it's the session layer as we see above there. So go ahead and type that in here. What is the technical term for when a connection is successfully established? And what was that? Session is created, so it's going to be session. Here we go. What is the technical term for small chunks of data? Remember, that was packets, right? So there we go. Now let's continue on to task number 5 here, going over the layer 4, which is the transport layer. Layer 4, the OSI model, plays a vital part in transmitting data across a network and can be a little difficult to grasp. When data is sent between devices, it follows one of two different protocols that are decided based upon several factors. You got TCP and UDP. Let's begin with TCP. The Transmission Control Protocol, TCP, potentially hinted by the name. This protocol is designed with reliability and guarantee in mind. This protocol reverses or reserves a constant connection between the two devices for the amount of time it takes for the data to be sent and received. Not only this, but TCP incorporates error checking into the design. Error checking is how TCP can guarantee that data sent from the small chunks and the session layer, layer 5, has been received and reassembled in the same order. Let's summarize the advantages and disadvantages of the TCP in table below. All right. So just briefly go over this here. Advantages of TCP: guarantees the accuracy of data, capable of synchronizing the two devices to prevent each other from being flooded with data, performs a lot more processes for reliability. Disadvantages: requires a reliable connection between two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. A slow connection can bottleneck another device as the connection is will be reserved on the receiving computer the whole time. That's right. If it's still open, the connection's not closed or whatever, then yeah, it's gonna cause some issues probably. TCP is significantly slower than UDP because more work has to be done by the device using this protocol. Right? It's got to do all this stuff. Right? It's worried about integrity, not really worried about speed too much as compared to UDP, where UDP's used more in like streaming services like like YouTube and such, right? All right, TCP is used for situations such as file sharing, internet browsing, or sending email. The usage is because this services require the data to be accurate and complete. No good having a or half a file, right? And the diagram below, we can see how a picture of a cat is broken down into small pieces of data known as packets from the web server, where the computer reconstructs the picture of the cat into the correct order. All right, and there's an example here, packet one, two, three, four, final, and reassembled it, right? And now you have the whole picture of the cat there. Now let's move on to the user datagram protocol, or UDP for short. The protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer whether it gets there or not. There is no synchronization between the two. Devices are guaranteed, just hope for the best and fingers crossed right. I like to call this the fire and forget method, right? Whilst this sounds disadvantageous, it does have its merits, which we'll lay out in the table below. Advantages: UDP is much faster than TCP, as I said above. UDP leaves the application layer user software to decide if there is any control over how quickly packets are sent. UDP does not reserve a continuous connection on a device as TCP does, and some of the disadvantages of UDP are UDP doesn't care if the data is received. It is quite flexible to software developers in this sense. This means the unstable connections result in terrible experience for the user. Yes, right. That comes in play when it comes to like lag on your streaming service or watching YouTube, right? No one likes lag or latency. And let's continue on. Using the same example as before, you can see how that the only packets 1 and 3 have been received by the computer, meaning that half the image is still missing. And there's an example here, right? Looks all jacked up. All right, UDP is useful in situations where there are small pieces of data being sent. For example, protocols used for discovering devices, ARP and DHCP that we discussed in room 2, Intro to LAN, or larger files such as video streaming, which is okay if some of the part of the video is pixelated. Pixels are just pieces of data. All right, and all right, let's gotta see which. Forgot which one. Oh yeah, transport. Right, transport layer is what we're talking about now. All right, so let me type that in here. All right, and this was a transmission. If I can spell right, I'm just going to copy and paste it from the top here. Transmission and control protocol. All right, and the next one was the user datagram protocol. I believe was the next question. Yep, exactly. So go ahead and find that up here. There we go. Just to make things easier. All right. What protocol guarantees the accuracy of data? Remember, that's TCP's got all that error checking and such in there. And the protocol that doesn't care if data is received from the other device, right? That's UDP. Remember, it's the fire and forget. There we go. What protocol would an application such as email client use? Well, that's going to be TCP, right? What protocol would an application that downloads files use? And that should be TCP as well, right? Because that said, who wants to have a file, right? Went back to that cat image up above. And for streaming services, right? That's going to be the UDP because we don't really care if it's pixelated or not, right? You're still going to get the video footage of it or whatever. So let's continue on to layer number 3 here. We're going to talk about, which is the network layer. The third layer of the OSI model, network layer, is where the magic of routing and reassembly of data takes place from these small chunks to the larger chunk. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent, while some protocols at this layer determine exactly what is the optimal path that data should take to reach a device. We should only know about their existence at the stage of networking module. Briefly, these protocols include OSPF, which is Open Shortest Path First, and RIP, Routing Information Protocol. The factors that decide what route is taken is decided by the following: what path is shortest, i.e. the least amount of devices that the packets need to travel across; what path is most reliable, i.e. have packets been lost on that path before; what path has the faster physical connection, i.e. is one path using a copper connection slower or a fiber connection, which is considerably faster, right? At this layer, everything is dealt with via IP addresses such as 192.168.1.100. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices because they are capable of working at the third layer of the OSI model. And here's an example of routers, right? And let's see, this was the network layer. So that in there. Will packets take the most optimal route across a network? And I believe that was yes. What does the acronym stand for? So I'm going to copy and paste it up from above. Open shortest path first. There we go. And the next one's probably going to talk about RIP. Exactly. So I did that. and RIP was the routing information protocol, right? So we'll go ahead and copy and paste that down below. Okay, here we go. What type of addresses are dealt with at this layer? Remember, it's IP addresses, right? Because we're working at the network layer, dealing with routers and such. Network, or sorry, IP address. There. Okay, now let's continue on to task number 7. We're going to get into the data link layer. All right. It says the data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds in the physical MAC, which is the media access control address of the receiving endpoint. Inside every network-enabled computer is a network interface card, also known as a NIC, which comes with a unique MAC address to identify it. MAC addresses are set by the manufacturer and literally burnt into the card. They can't be changed. Although they can be spoofed, when information is sent across the network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it's also the job of the data link layer to present the data in a format suitable for transmission. And this is the data link layer that we're talking about, right? So there we go, data link. And what is the name of the piece of hardware that all network devices come with? Remember, that's the NIC, right? Network interface card. So there we go here. There we go. All right, continuing on to task number 8 here. We're going to get into layer number 1, the physical layer. All right. This layer is one of the easiest layers to grasp. Put simply, the layer references the physical components of the hardware used in networking and is the lowest layer that you will find. Devices use electrical signals to transfer data between each other in a binary numbering system, ones and zeros. For example, Ethernet cables connecting devices such as the one below. You go, Ethernet cable, also known as a network cable. What is named this layer? Remember, it's the physical layer. There we go. What is the name of the numbering system? That's binary, right? Computers talking ones and zeros and such. What is the name of the cables that are connected to the devices? Ethernet cables, the proper name, but everyone knows them as network cable, all right? And let's continue on to task number 9 here, practical OSI game. Can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reel the flag. Can you beat our staff high score of 19 seconds? Click the view site and then let's get into it. Okay, well, let's go ahead and give this a shot, folks, and see what we can do here. And let's see. Our hacker has been locked in the dungeon. Their only chance of freedom is by choosing the correct path based on the OSI model. Use your cursor keys to move left and right in the space bar to enter the doors. Okay, so let's give this a shot, I guess. All right, so we're starting from the bottom, right? And let's get over here. It's going to be physical. All right, and then layer 2 was the data link layer, and layer 3 was the network layer, and layer 4 was the transport layer, right? And layer 5 was the session layer. Okay, and layer 6 is the presentation layer, and the last one is the application layer. All right, well done. Okay, we didn't beat the high score, but hey, we got the flag, right? So there we go. Now, remember what I said earlier about that little acronym that you can remember, right? You can do it either from 7 to 1 or 1 to 7, right? So 1 to 7 would be, please do not throw sausage pizza away. And then from 7 to 1 would be, all people seem to need data processing. All right, now let's continue on to the last task here. Let me go ahead and minimize this. All right, and task number 10 here, continue your learning packets and frames. Continue learning by joining this packets and frames room. All right, and that wraps it up, folks. Hopefully you found this video of value. And if you did and you're new here, please consider hitting that like button, hitting that subscribe button with the notification bell so you know anytime I post. Comment below your thoughts and opinions on the information shared. And as always, thank you for watching. Have a nice day, and I will see you later.